In today's lesson, we're continuing to look at different techniques for finding equivalent expressions. Now, today's technique is called factoring, and you'll find that the way we approach it is very similar to what we've just learned recently. So factoring is the opposite process of distributing. One way to do this, and the way we'll look at today, is to find the greatest common factor, which we can abbreviate as GCF. The first factor to find is the greatest common factor of all the coefficients. Let's see some examples of this in practice. We have the expression 7n take 21. Now, because factoring is the opposite process of distributing, we can still use the box method. What's different here is that the expression we have now goes inside the box diagram. We're trying to work out what goes on the outside. Now, 7 and 21 have the greatest common factor, 7. So we're going to use that as our common factor, and we need to work out what we need to multiply that factor by to get the terms that we already have. To get 7n, we would do 7 times n, and to get negative 21, we would have 7 times negative 3. So we've just shown that our expression is equivalent to 7 times the quantity, n minus 3. For the expression 10x plus 16, we can find the common factor of 10 and 16, which is 2. To get 10x, we would need to multiply 2 by 5x, and to get 16, we would need to multiply 2 by 8. So our expression is 2 times the quantity, 5x plus 8. If our expression is 15m take 50, our common factor is 5. To get 15m, we would multiply 5 by 3m, and to get negative 50, we would multiply 5 by negative 10. So our factored expression is 5 times the quantity, 3m take 10. For the expression 6a minus 30, our common factor would be 6. Now we could use a common factor of 2, or we could use a common factor of 3. However, that wouldn't be the greatest common factor, so our expression wouldn't be as factored as much as it could be. We should always use the greatest factor that we can find. To get our expression, we would have to multiply 6 by a and negative 5. So our factored form is 6 times the quantity, a minus 5. For 28x plus 70, we have the common factor 14. With that common factor, we would be multiplying 2x and 5. So our factored form is 14 times the quantity, 2x plus 5. For 105t plus 45, the common factor is 15. To get our distributed form, we would have to multiply 15 by 7t and 3. So our factored form is 15 times the quantity, 7t plus 3. Now, so far, our common factor has always been a constant number, but that doesn't have to be the case. If all the terms share any variables in common, these are also factors of the GCF. Let's look at the expression x squared plus 8x. Now, the coefficients here don't have any factors in common. But if we look at the variables, we see that both terms contain x. So we can use x as our common factor. Now we could get x squared by having x times x, and we could have 8x by multiplying x by 8. So our factored form is x times the quantity x plus 8. For y squared, take 12y. Again, our coefficients don't have a common factor. But looking at the variables, y is a common factor. It occurs in both terms. To get y squared, we would multiply y times y, and to get negative 12y, we would multiply y by negative 12. So our factored form is y times the quantity, y take 12. For the expression 2a squared take 14a, we see that our coefficients do again have a common factor. It's 2. But if we look at the variables as well, we see that both terms contain the variable a. So our common factor is actually 2a. Now to get 2a squared, we would multiply 2a by a. And to get negative 14a, we would multiply 2a by negative 7. So our factored form is 2a times the quantity, a take 7. For the expression 8st plus 4t, we see that for our coefficients, a common factor is 4. If we look at the variables, a common factor is also t. Note that s is not a common factor here. While it is a variable in this expression, it only occurs in the first term, not the second one. Only t occurs in both. So our common factor is 4t. Now to get 8st, we would multiply 4t by 2s. We need to multiply by 2 to turn the 4 into 8. And we also need to multiply by that variable s as well. Now our final term is already 4t. We don't need to multiply by anything. But we need to put something in this place. Well, we're going to use 1 here. That's what you would multiply 4t by to get 4t. So our factored expression is 4t times the quantity 2s plus 1. For the expression 12x cubed plus 15x squared, our coefficients have the common factor of 3. Now for the variables, both terms have the variable x. But if we think carefully about this, x cubed is actually x times x times x, and x squared is x times x. Both terms have the variable x multiplied at least twice. So we can actually use x squared as our common factor here. So our full common factor is 3x squared. To turn this into 12x cubed, we need to multiply by 4x. And to turn it into 15x squared, we need to multiply by 5. So our factored form of our expression is 3x squared times the quantity 4x plus 5. Now for the expression 4a squared b, take 7ab. We don't actually have a common factor for our coefficients 4 and 7. But if we look at the variables, we do have a couple of common factors here. Both a and b occur in both terms. So our common factor is ab. Now to get the term 4a squared b, we would have to multiply ab by 4a. And to get negative 7ab, we would need to multiply by negative 7. So our factored expression is ab times the quantity 4a take 7.